This is the first part of 2 videos covering IPv6 concepts. We will discuss writing and reducing 128-bit addresses, prefix length concepts, and the 2 types of addressing, private and public. The size of an address in IPv6 is 128 bits, which is 4 times larger than an IPv4 address. An IPv4 address is a 32-bit address, permitting an address space of over 4 billion possible IP addresses. IPv6 uses a 128-bit address space and permits an address space of 2 to the power of 128 addresses. This equates to more than 655 sextillion addresses for every square meter of the Earth's surface. Because IPv6 addresses are so large, they are typically represented in hexadecimal format, instead of the decimal notation typically used to represent IPv4 addresses. IPv6 addresses are broken down into 8 groups of 4 digits or 16 bits separated by colons. Here are a few examples of typical valid IPv4 addresses that illustrate this IPv6's naming scheme. Because IPv6 addresses are so long, the IPv6 standard provides a few simple rules for simplifying their notation. 2 of these rules are discussed here, including name of : rule, name of leading 0 rule. The first rule uses a double colon to represent a group of multiple groups with consecutive 0 values in an IPv6 address. It bears repeating that this rule only applies to groups that consist entirely of zeros. Groups like 0001 cannot be shortened by this rule. This rule can only be used once per address. Each node or device can expand the value by calculating the number of bits missing and replacing them with zeros. Let's look at how our new rule applies to our previous set of IPv6 addresses. The second rule allows the leading zeros in each IPv6 group to be omitted. For example, a group consisting of 0001 could be reduced to 1. Unlike the first rule, the second rule allows us to simplify individual groups like 0001. Let's apply this second rule to our already simplified addresses and see how they become even more simplified. IPv6 is similar to how IPv4 uses the prefix length in the subnet mask to determine network and subnet. An IPv6 prefix length is written as a slash followed by a decimal number. The prefix length, which will be an integer between 1 and 128, illustrates how many bits of the IPv6 address define the network and subnet. Here is an example of an IPv6 address including a prefix length. The network prefix shown is indicated by /64. This prefix includes an encoding of its 48-bit IPv6 global routing number, an encoding of its 16-bit internal subnet ID, and an encoding of its 64-bit interface identifier. /64 prefix lengths are by far the most common. However, you should still be able to manage IP addresses using a prefix length that is different. In particular, when using a prefix length that happens to be a multiple of 4, you do not have to think in terms of bits. You can think in terms of hex digits. This means that you can take the prefix number, divide it by 4, and subsequently use that number to help identify your network address. Consider the following address. 56 divided by 4 is 14. Moving from left to right, you count over 14 hex positions, and the rest of the hex digits will be 0. Resulting in the following network address. Here are a few examples to practice on. Welcome, and thank you for taking the time to consider using our Cisco AlphaPrep software suite with Pass Guarantee. If you are currently preparing to take a Cisco certification exam or are simply looking to brush up on existing Cisco networking skills, then you have come to the right place. It's no secret that there are many different online solutions in the market today, but let us explain why we feel Cisco AdaptPrep is unique. Unlike other solutions, we go to great lengths to first understand your knowledge level. Traditional competitors tend to treat each learner as if they are all the same. Consider for a moment, you are someone who has been preparing for an exam for the last 3 months. Challenging you with trivial questions will waste your time. On the other hand, if you are brand new to a subject matter, challenging you with advanced questions will be confusing and will prevent you from learning effectively. With AdaptPrep, we first analyze your skill set on a personal level. This allows us to provide you with questions that will challenge you appropriately, allowing you to learn efficiently. At AdaptPrep, we take great pride in building your test-taking confidence. Many solutions offer comprehensive testing content. However, most lack the ability to understand when you are ready to take your exam and successfully pass. Understanding this principle is something AdaptPrep excels at. It does so by utilizing an earn level concept. The earn level concept is simple. When you start using AdaptPrep, your earn level will be 0. As you progress, it will continuously advance. Once your earn level reaches 7, you are ready to take your exam and pass. We are so confident you will pass your exam once your earn level reaches 7, we guarantee it. Again, we would like to thank you for your interest in our AdaptPrep software. We look forward to working with you in the future.